first, we talked about that address on IP version 4 last week. And I still got the submitting chart on the board here. Actually, not submitting chart on the board. But the classes and the type of addresses. Have y'all got any questions on the IP version 4? Where we went through the different things on the addressing. So now we're going to talk about IP version 6 in chapter 12. Some of the information in this chapter is similar to what you had in the previous chapter. That we're moving to IP version 6 at this point, and actually have been for 20 years now. So the first thing they talk about in the chapter is the reasons for using IP version 6 and the problems with IP version 4. So we've been through seeing how the addressing is set up and all of that in 4. And then, given that there was 4.3 billion addresses available in IP version 4, except for that there really wasn't that many addresses available, okay? But the way that it was set up, there was a lot of wasted addresses, just like I showed y'all on the loopback address, that they had an entire class A address out there for loopbacks, which we had given meant there was 16 million addresses used there for something that they didn't need all of those addresses. Okay? So there was a huge wastage across there. So 4.3 billion didn't go very far. Second thing is, with the rapid growth of the internet since the mid-90s, that there is a whole lot more addresses needed than that out there today. And it's continuing to do rapid growth. Because there are parts of the world that the internet's really just arriving at. Okay? And that's part of what several big projects are out there trying to do, is get the internet to a lot more areas of the world. And so that didn't go very far. IP version 6, as it was developed, allows for 340 unidexiclium, I guess that's how you say it, unidexiclium. That's 340 followed by 36 zeros. Okay, so that is a ton of addresses out there. I have heard that really is that we could put an address on every grain of sand in the world. Now, whether that's true or not, I don't know. Okay, but that's what I've seen several statements made on some places. I'm going to not believe that statement, but that's what I've heard. I think there'd be a lot more sand than that in the world. But it is a huge address. So what they did, and actually when they began work on it, it was originally supposed to be IP version 5. So we really do skip a number right there. But they were looking at other things than number of addresses out there as they were working on 5. Because they were looking at some of the other things mentioned in the book here. To figure out how to better make it a more secure network, etc. And then the World Wide Web arrived in the midst of that, or it had arrived in the midst of that and took off. And suddenly we were running out of addresses, and that became the primary item of IP version 6, although security is a big one on it too. And so to redesign it in terms of solving that problem, they just changed the number on it and just dropped IP version 5, although they stayed with the things they were trying to do. 5, but because they wanted to change it so drastically in the process there where they were, they renumbered it. So there's never been an IPv5. Okay, so we've gone from 4 to 6. There was a proposal for 5, but there's never been a 5. Okay. So then they mention here in the book about running out of IP version 4 addresses. I'm not sure where they got some of these dates from, because it definitely ran a lot longer than that. Okay. They said we ran out of addresses, I think it was 2 years ago now. Okay, it's just been a couple of years. It's not been 6 years ago. Okay, and notice those were type projected things on it and claiming that they ran out way on back then. Okay. So, but they've now, about 2 years ago, they said they had run out of addresses. Now, it hadn't really completely, we really weren't completely out of addresses, but they were out of addresses to issue from major places. Okay, as they're starting to show on that. And so, on there. So it's been later than what they're showing on that chart. So, but we had originally run out of IP version 4 addresses somewhere 98, 99, that we ran out of IP version 4 addresses before. Okay. Then we went to using NAT, and NAT got us an extension on that, and pretty much got us another 20 plus years. Okay. IP version 6 was being developed at that point and had gone into crunch development, but then they came up with NAT, Network Address Translation, and using the public and the private address schemes, that went, wait a minute, we'll be able to do some things differently. So they tried pulling all of the addresses back in from everybody and just giving them the number of addresses they really needed. Now, it didn't work in all situations, because in a couple of cases, and I believe it was AT&T, actually sued and said they wanted to keep their address and they belonged to them. And the courts actually ruled for them and said you can keep it. Okay. I say, I think it was AT&T. I don't think it was IBM. I'm pretty sure it was AT&T, but it was one of them. Okay. Because they wanted to keep their Class A address. That was one of the big companies. And as far as I know, they still have that address. Okay. And I say, I'm not sure which address it is, other than it's a Class A address. Okay. Everybody else, they got them back from different people. But they had made the mistake in the first place, early on in IP version 4, that instead of leasing addresses out to people, and when you lease something out there, you don't have to charge for it actually, but But you just give it to them for a designated time period. Which can be a real long time period. But it's a lease on it, so then it can be reclaimed if situations change. They had actually, the way it had been worded originally had been that they were giving organizations those addresses. So they pulled them back in, then issued them back out. They didn't have to pull them all back in to do that. But as they started pulling them back in, an organization voluntarily gave up their address and were given a new address. Okay? Which, as we're moving into the World Wide Web, the IP address wasn't quite as critical to staying constant as it was before. Because before we had domain names, having a steady and constant IP address was much more critical. But they had given them out incorrectly. So, we were in that factor. So then they went to using NAT. With NAT, you could use in most organizations that your organizations could exist in a lot of situations with just one IP address, one public address, and then they used all private addresses inside the organization. Instead of a ton of public addresses inside the organization, they were private. Besides that, that actually helped on security, which was one of the objects of going to the next version of IP. Because no longer could you directly contact a machine easily, because you didn't know what the exact address of the machine was. Okay? And it was the NAT server that kept track of things. And it didn't have a permanent one-to-one relationship of how an address got used and how in the machine. That it was changed, and so that meant from a hacking viewpoint, it wasn't as easy to get into it. Before we went to NAT, you could sit at your machine right here, and if you knew the address of the machine somewhere else, you could just go straight to that machine. Okay? And you could access it, etc. Now, depending on how the security was set on it, whether you could actually get into it or not, but it was a real simple thing of get to any machine you want at any part of the world, which fit with the original concept of the internet, that it was supposed to be universally shared information, etc. Except for that you had security to secure certain things off, like military machines. Okay? So we went to NAT. NAT said we could use basically one address for an organization, be shared by all of the private addresses inside of it. So the school here only needs essentially one address. We've probably got about 3 or 4. I'm not exactly sure how many, but most places bigger like this have got several. As we may, I don't think we do this, but in some cases, because I think we really actually go out one central point and everything goes to Rome and goes out. Okay. I think it's to Rome. It's not to Roxbury, but I'm pretty sure it's to Rome. But they've got us the outside connection. So there's really not an outside connection to this campus that has got to get to the other campus to go out. Other places would choose to put a public address for each of the campuses. Okay. A lot of organizations will use a different public address to go to their web server / servers and have that on a different public address than the communications in and out from the machines with them. Likewise, if they got some other specialized servers that do special things, they may have a public address for them for whatever their purpose is. But most of the stuff all sharing one address. Now, you can do things with NAT that will allow you to still get into a machine from outside, that we can actually do things called pinholes in NAT. and set it up where somebody can come in from outside to get to a specific machine. So if Nathaniel needed to get to his machine from outside, we could actually set up, and there's other ways to do this, like what I'm going to tell you right here, because you can use some more programs to do type approaching too on it. But you can set up a pinhole in NAT, and where then, as long as he knows what is the protocol that we've got set on it and the port number that we're using, particularly the port number, know what the port number is that we have assigned to his, for his bit on to get to his machine. He'd be able to access his machine from outside by going to that public address on a specific special port. And there's 65,000 ports out there, and pretty much anything over 46,000 or thereabouts, the exact number, are usable addresses that you could use. Okay. A lot of the other port numbers are pre-assigned for special purposes, so you have to be careful further on down, lower numbers, but it's not a port number you're actually using by the supplies in the organization. Then you could go to that port number from outside. When it hit NAT, it look at it and go, it's for that port number. That means actually that needs to go to this specific machine. So then to point to Nathaniel's machine. Y'all follow on that? And the communications go back and forth. That in itself has got a little bit of security to it, because you got to know what the port number is to get to his machine. And then number two, Nathaniel should have security set up on his machine, so if you did get to it, you still had to log into the machine and everything. Okay. Now, second thing you can do is you can use remote desktop to do the same type thing, as long as, again, you still got to have that pinhole through there, or you got to have it set up where it's been established. Here's the way to get to that address, okay? You can't just use the private address that's sitting on Nathaniel's machine, but you can use using remote desktop connection, okay? Now, for instance, the school is using that to get to faculty machines, so that if I know my machine name, and they've actually got it set in that if I go through their VPN, their virtual private network connection, that then that gets me into the school network. And once that lands me in there, then I got to have the right security settings to get in it. It lands me actually on the school network. Then I connect to the machine using remote desktop connection. Okay? Well, that's nice and good. But with IP version 4, there was the limit on addresses, and we ran out of addresses. And then we've run out of addresses again within the last few years. Okay? And even though the chart says that there's been places out of them since 2011, it's not quite. I know those numbers aren't quite right on that, okay? I'll have to look them up and see what it's supposed to really be. That's the big organization has run out of addresses to give to the next level, to your internet providers, okay? The internet providers have still got addresses because they're getting addresses back occasionally by organizations that quit using addresses, etc. And that they've still survived. So we're really not out of addresses totally, that they're still playing back and forth, and that, for instance, when they give to your internet provider a set of address, they give them a big chunk, and then they give off just small pieces of just 1 or 2 addresses to an organization. Well, from the higher level, they see those addresses as gone, but they're really not all gone, okay? So there's addresses they can play around with. So we continue to exist on it and to be out there. So now there are a lot of things using IP version 6. The other problem there in the 90s was all of the equipment was built just to use IP version 4. IP version 6 uses much longer packets, using the addresses, remember, 128 bits versus 32 bits. So you had to have equipment that could work with IP version 6. So that had to start developing, and then you had to replace the equipment. Well, now 20 years later, the equipment's out there that supports IP version 6, and that there's very, very little equipment left sitting out there on the internet that doesn't support IP version 6. So that limitation's gone now, okay? Because if you go and buy a piece of networking equipment, it's going to tell you it's compatible for 4 and 6. And that's where they talk about dual stack, is that dual stack says something will work with IP version 4 and will work with IP version 6, okay? And that we've got the things set up where they handle both ways now. You may or may not have an IP version 6 address, but you're able to get to IP version 6 stuff because they can flip addresses as you're going back and forth across. The government has determined several years ago, and they actually do a test every year, and I think it's in May, because there's actually an IP version 6 day each year, and I think it's somewhere in May, but don't ask me what date. And the government actually, the federal government actually tests each year to see if all of their equipment will work on IP version 6 that day, and does not use 4 on that day as they're determining on that. A couple of years ago, more than a couple of years ago now, probably about 10 years ago, they determined that they were fully functional for IP version 6. So that had been back when Bush, George W. Bush was president. One of his things was that he had put out an executive order that everything was supposed to be IP version 6 compatible of the government before the end of his term. So it was somewhere along before 2008 or something. They had a specific date on it. Agencies all have to report each year that they comply. So that whenever as things switch on over, that the government's fully working on it. However, they're still using IP version 4 at this point also. Okay. There's plenty of things out there still using just IP version 4. Your internet service provider, your ISP. Some of them, particularly the smaller ones, are still working on just giving out IP version 4 addresses. So if you go home and do an IP config, you may see your machine assigned an IP version 6 address, or you may not. Your router may or may not have a 6 address to it. Okay? Most of them do now, but not all of them. Although, unless you're using a really old computer, and when I say really old, it's going to have to go back to before Windows XP. Actually, before Windows 2000, and maybe you go back to 98 or before, it may or may not support IP version 6. Okay, but if it's Windows XP or newer, it will support IP version 6, but you may not be using it. Okay. So be aware of all of that and how that's all working. So today, we're still predominantly using 4. And actually in the newest things, which you would think would be using purely 6 on their approach to things, things like AWS, Amazon Web Services, their cloud. Okay? If you set up addressing in AWS in a cloud that you've got out there, you'll actually use IP version 4. Okay? And they actually give you an IP version 4 address. You would think they would be 6 because they came along after all of this occurred, okay? Because PWS, which is essentially the first public cloud out there, dates to 2007 or 2008, I believe is when they started. And as an AWS ambassador, you would think I would know the right date on it, but it's somewhere back about then when they started into the public cloud. They are still right now, when you take any training from them or you go to do addressing out there, you can build entire networks out there on the cloud. It's using IP version 4. Okay. Basically, for the reason that IP version 4 has got these shorter addresses, it's got this nice little scheme that everybody understands, and that you now understand from last week. Okay. So IP version 4 is still there, but IP version 6 is coming. You've got things, you can read articles out there that say IP version 6 will be completely here and 4 gone in 2 years. Okay? You can go back and read old articles from 20 years ago and find exactly the same comment. Okay? Because in 98 or so, they said we'd have to be completely IP version 6 within a couple of years because the internet was collapsing under this whole addressing issue. They didn't. Because we found ways around it. My expectation is, and this is just my personal opinion on it, is that IP version 4 will probably still be around, used a fair amount, for at least 5 or 10 more years. And with places like AWS still pushing heavily on doing 4, probably longer, okay? But it's going to be here. So you need to know what's in the previous chapters. Okay, we'll talk about it before. But 6 is coming. There's more and more stuff being done 6. But when you're setting up a lot of networks today, you're still not doing a lot with doing them as PP version 6 addressing. Second thing is it does itself automatically. So they talk about dual stack, mention dual stack. What that just means is that it allows both versions of IP to work together. Tunneling is also mentioned, which is just where IP version 6 travels across an IP version 4 addressing network. Okay? So you can do 6 traveling within 4. And then they mention translation about NAT version 6, NAT 64, which allows your version 6 enabled devices to communicate with version 4 devices using a thing of NAT that's similar to NAT version 4, but we've already talked about. And so it's just doing a conversion in and out on it. And that's out there allowing it all to work on it. Okay? So that's the reason we're on going to 6 and that you need to know 6 now. But 6, there's not a lot that you're going to have to know in here. It is going to look complicated in some ways, but keep it down easier on yourself on it in some ways on it, okay? Most things ask you questions about 4 still, okay? So they talk about that IP version 6 addresses are 128 bits long. Exactly how we express them varies, but usually, but those 128 bits is one, you're going to look at it normally in hexadecimal, which was a reason you had to learn hexadecimal, okay? IP version 4, we normally look at them in decimal. So, you're going to see they've got letters and they got numbers because it's hexadecimal. With that, the letters in hexadecimal are not case sensitive, so we don't use uppercase letters and use lowercase letters. It's so letter. Okay, y'all follow on that? Now there's other things that yes, case sensitive on letters is significant to you, okay? But on hexadecimal, an uppercase A is the same as a lowercase a. So you'll see that expressed both ways. Now, it is 128 characters long in bits. Expressed in hexadecimal is 32 hexadecimal characters. Because remember, one hex character can represent 4 bits. So it's 128 divided by 4 gives you 32. That's still a lot of stuff right there. That is what they call preferred format when you show it completely out every hex character. Although it's really not preferred format. Okay? It is what's called preferred format, but that's not what people really prefer to use. Okay? There's ways to shorten that up. So they go through a couple of rules on that. This is parts you need to be aware of. Okay? It's expressed in groups of 4. And you will see addresses, sometimes the IP version 6 addresses. Normally we separate them with colons in groups of 4, but sometimes you'll see people will use dashes to separate the groups of 4. But you really ought to be using colons. It's sort of like when we talked about MAC addresses before. Remember, it expressed it in groups of 2, but people weren't consistent on how to build that one, although it's usually dashes separating them, but not always. Sometimes you'll see colons on that. So be aware it can be, people will use different things there. There is no arbitrary. So the first one is, to shorten it up, if there's leading zeros in each group of 4, you can actually drop the leading zeros and shorten it down. Y'all follow on that? So it's 0A00. That can be put out there as just A00. Leading zeros you can drop in each hextet. And each of those groups of 4 is a hextet. Because remember, on IP version 4, each of the sets of numbers, each of those 4 sets of numbers was an octet, or these are hextets. Okay? Your online dictionaries may or may not have hextets in there. I've seen some that do, some that don't. So when you're typing something up, it may tell you hextet, H-E-X-T-E-T, is misspelled. Okay? And the word's been around for 20 years. You'd think, and on computer dictionary, online dictionaries, you'd think they'd have that word in there, but they don't all. Octet usually is all there. I don't usually get misspelling marks about that, but Microsoft's dictionary, for instance, for some reason, doesn't seem to usually have hextet. I don't know why. So we can drop leading zeros. Well, that can reduce down the size of it a good bit. Okay? So that's what they call Rule 1. Rule 2 says that when there's a number of hextets, actually it doesn't have to be a number on them, when there's one or more hextets right beside each other, they're all zeros, we can actually drop that hextet from showing and just use a double colon. Now, you can only do that once in an address on Rule 2. Rule 1, you can do all the way across. And every hextet that has leading zeros on it, you can drop the leading zeros. Okay? But where you drop showing all of the hextets because a number of them have all zeros, that can only be done once. If there's more than, if there's a couple of, if there appears a hextet with all zeros, then something else appears, and then there's another hextet or 2 or 3 with all zeros, one or the other you can drop in terms of the all zeros, but you can't drop both of them. Because here's the problem. If you drop both of them, you don't know where in there exactly how it falls, okay? Or how many actually, you know where they fall, but you don't know how many there are if you had two spots on it, okay? So you can only do it once, and you put a double colon. So we can have an address. Or we can have an address that looks like that, okay? So we got 32 characters up there. There's no leading zeros on any of these, so we can't get rid of that. But we've got two all zeros here, and we can all zero here. So we can actually shorten this down to 2A 0 0 colon colon 1 3 4 6 colon, and we have to use the all zeros on this one. But we got short, so we took two hexadecimal out there. Y'all follow on that? We can also do, which is actually the loopback address. We can take that address that's got 7 octets of all zeros and one hexadet that's got just 3 zeros and a 1. And what can I express that address down as? And that's actually the loopback address for IP version 6. What would be an easier way to express that address? These are all zeros, each one of them. They're all together, so we can get rid of them. And we can just do a double colon to start with. And then we can put this last one. But what have we got on this one? We got a 1 there that had 3 leading zeros on, so we dropped the leading zeros. So we can express that address as colon colon 1. Y'all can definitely see where we saved a whole lot on that one, right? Y'all follow on that? Because in actuality, we've got 127 binary zeros followed by a binary 1, okay? And we can express it as colon colon 1. And that is the loopback address in IP version 6. That's the only address I can tell you what is in IP version 6, okay? But I can tell you that one. Because they picked a logical address for that one, okay? But it was an easy way to remember. So the double colon, we can only use it once in there, because if we change this one to a double colon, then the question would be, we know there would be 3 spots at the double colons between the two of them, but we wouldn't know where they fell. So you can't double colon twice in an address. Does everybody follow that part? So now, it's your choice when you're expressing it that how Drew decides to express it and how I express it, which one I choose to shortcut on and which one he shortcuts on is perfectly fine. So I did it this way. He may have chosen instead to put the 8 zeros there and then to double colon that one, and both addresses would be completely correct. Does everybody follow that? Because y'all can, the other three of you can look at what he and I both wrote down and translate it. Okay? So you can use, nothing says you have to use the one that's the longest. However, normally people are going to use the one that's got the most zeros that are limited. But for instance, say you had two groups of 3, all zeros in there. Which one you chose to use could be completely up to you. Okay? But you could use whichever one to shrink it down. So there are ways to shrink these things down from 32 hexadecimal characters. And at rule 1, rule 2, you'll see everywhere about that. And that's standard. That's how the standard is for IP version 6. That you can shorten these names. Just like in IP version 4, there are unicast, multicast, and instead of broadcast addresses, IP version 6 changes the name. You need it, we're going to do that to you, right? So that they got anycast now instead of broadcast. I don't know why they decided to do that, but they did. But anycast is a unicast address can be assigned to multiple devices. So you can actually have a unicast address that's put out there, are different ones, but we're not doing that. It really doesn't have a broadcast address. The multicast takes care of broadcast for it. Now here's the other part on it. It does have prefixes on it, so it's got just like IP version 4. We've got part of its network portion, part of it is host portion. Okay. Normally, the first 3 hextets are going to be the network portion. The 4th hextet will be a subnet hextet. And then the last 4 hextets will be your host portion. Okay? Y'all follow on that? Now, notice right there, we've got a hextet reserved for subnet. You don't have to do all that stuff we just dealt with in IP version 4 in the last part of the previous chapter. We got a whole hextet to use on that. Okay? So, they talk about the unicast addresses. There's different ones of those that they have all these specialized names on. A global unicast, a local link local, a loopback address, which we've already mentioned, an unspecified address, which actually looks like a loopback address there, a unique local, and then an embedded IP version 4. But you can actually put your IP version 4 address into an IP version 6. Okay? Now, the global unicast address, GUAA, and the link local address, the LLA, you're going to normally have those on every machine. So now we're going to use multiple addresses on a machine. If you do an IP config, you'll see it gives you multiple IP version 6 addresses. The link local is the one that is assigned specifically to your machine. Now, most of the time, it actually uses in there, in terms of the link local ones, that it does uses your MAC address as part of the address, and it builds the IP version 6 address off the network you're on and using your MAC address, and flips 1 bit. So it makes it slightly different. 1 bit in that MAC address, it flips. Unique local addresses, it says we're not fooling with those yet. And that they're saying those are going to be used for internal purposes within a network. The GUA addresses, the global unicast addresses are unique and routable on the whole thing. And so then on that, they've got a unique parts tool. The subnet ID, like I've mentioned to you, should be the 4th. It is the 4th hextech. Okay, that's what I was thinking. I remember it's a 314. Okay, and so 3 tells you the network, 1 tells you the subnet, and the last 4 tells you which host it is on that network. Okay. You don't have classes A, B, C, D, E, any of that type of stuff, so everything's 314. So you just have to know one thing about the network versus the host address. Now think about that with hextet 4 being used for subnet. That means we can have subnets that have numbers from 0 through FFFF. That's way more than 10,000 subnets you got per network. Because you get to 10,000 without even going into the letters. And then you got letters A, B, C, D, E, and F. I really don't know any networks out there that have got 10,000 subnets to them, much less more than 10,000, or even 1,000 subnets to them. There may be with 1,000 subnets, okay? But I don't see anything a whole lot larger than that. I could see possibly in a real large organization that you may subnet it down, end up with 1,000 subnets, okay? I don't know how you get it, but so they came up with an astronomical number beyond anybody's comprehension at this time, okay? But they didn't waste a ton of addresses on that. That's one hextech. Now, versus when IP version 4 was created, there was no thought about subnetting, actually. Subnetting was something that got introduced to it later when they went, wait a minute, it would be really nice if we could spread our networks out there and make them a little bit secure. It's then that part of the room that y'all are only allowed to get onto a specific subnet and access certain types of information. This part of the room, y'all can only access other stuff. You can't access their stuff. And y'all can't access their stuff. And it would make it much securer because we don't want y'all both getting into the other type of stuff. So we could use subnetting to do that. So that was something that came along later. Okay? It wasn't something when they first introduced IP version 4 they even thought about. So it was 1980. It was small networks within organizations, and it was just in your network organization, and you weren't connecting networks to networks. You did have the internet out there, but you were doing very limited on that. Most things were purely private ones, and there was very little of doing things beyond that. Now, keep in mind on IP version 6, all of these things we keep saying have got, and that we keep reading that they've got unlimited amounts for them. I wouldn't depend on that. Back there at the beginning of the chapter, we sort of skipped on over it, that it mentioned about with the Internet of Things now, that there's all kinds of addresses needed that we've never dreamed before. We're also moving into a whole new thing out there of been science fiction up till now, but it's now realistic. And that is regular humans traveling in space and going to other planets to inhabit them. Because you've got SpaceX and such taking reservations to go to Mars to settle it right now on a one-way trip. And others, and that those different ones of the leaders of Tesla and Amazon, both having their own separate space companies, Musk and Bezos. I hope I must name could continue for a moment. And that their big push is that they're intending to start where we'll be able to travel in space, normal people. Because up till now, with just one or two exceptions, just a couple of little exceptions, everybody who's gone in space has been a trained astronaut from some country, whatever they call their astronauts, cosmonauts in Russia or whatever, they're all astronauts, okay? You've had just a very few non-astronauts get to travel in space. Because a couple of years ago, both the Russians and the Americans sold a couple of seats on their trips to the International Space Station to some people that could spend $1 million or something on taking a trip up there to the space station and back. But beyond that, everybody else had to go through all the training and stuff. And obviously, we had the teacher that died going up in space back there in the late 90s, or in the 90s. I guess it's when she died. I watched the launch on TV, but I can't tell you when it was. It was the class that day said they wanted to watch the launch, and they watched it blow up. Very few non-astronauts have gotten to go. And they're saying there'll be something we'll be able to regularly do. We'll fly to the moon in a few more years. So definitely, from everything they're saying now, in your lifetime, you may well be able to fly out and look at the moon. Maybe I'll get to too, but we'll wait and see. Because they keep saying we're going to have a mission to Mars going within the next couple of years. But at this point, they keep saying on it being a one-way mission. I'm going to turn that one down. That may interest y'all, but that's not real interest to me. It would be neat to fly to Mars and see Mars and then come back, but not real wild on go there and not be able to come back. But that expands our use of the internet and already has to those other planets, because where we just landed the newest rover on Mars, that thing's communicating back here across the internet. So we're doing interplanetary on it. So they talk about each of these a little bit. The subnet ID I've already told you about. The interface ID is just the part of the address that's specifically assigned to a mission. It's the host portion. But they call it an interface ID. Okay? Where 4 called the host. The LLA is used for communicating with devices within your network, not for outside. So then they talk about how they get configured on there. You can go in and put in actual addresses. Now here's the neat part on this. IP version 4, when you put in addresses on Cisco equipment, you have to put the full address and the full subnet mask out there. You can't use the shortcut on it. Okay? IP version 6, Cisco devices will let you do short names, like right here or here, not this one to this one. So you don't have to type out a whole long thing. You don't have to translate it back out before you type it in there when you're giving the address for an interface. Second thing is the subnet mask. You get to use shorthand method. You get to put it in as slash and the number of characters on it, which most often is going to be /64. you're saying the first 4 hextets are some type of network portion to it. It's the network plus the subnet, okay? Which is just like you did in IP version 4, except in IP version 4, you had to put the whole thing in decimal output. You couldn't, you had to put like 255, 255.0. You couldn't do /24. Everybody follow that part? Now you can do the slash and the number, /64. So /64 is a whole lot easier than typing all of the sets of numbers. So you're going to use the shorthand method you normally want, okay? As far as when you put the addresses into Windows, so if you're putting it into the Cisco device, it's really similar to what you did on 4, except that you're going to put it as IPv6 instead of IP. And that's going to be changed between 4 and 6. Because you'll have to put the v6 on anything that's a IP version 6 type of address. In Windows, that you can actually go into it, you've been choosing Internet Protocol version 4 to put your address in that. Well, there's an Internet Protocol version 6, IP version 6, that you can use also, and gives you a similar Windows, just like you were looking at in IP version 4, and you put your address in there. It will also let you use shortcut methods on it, okay? So where you've done double colon or drop leading zeros, it lets you do that also. So, and then for its subnet, the prefix, the mask, it uses a shortcut. And so you just put the short one on. So it's nice on that one. So you can assign static addresses to machines, or you can tell it to use DHCP v6. So there's a DHCP version 4 and version 6. Version 4 doesn't have a v4 after it, it's just DHCP. And then version 6 has a v6 after it. You'll use v6, some DHCP sometimes, but not always. A lot of times you're going to do dynamic approach on it, and they'll use router advertisement and router solicitation, which is working just like DHCP, but they came up with a new protocol working with it. So they use RS and RA messaging instead of where we did before advertising and where we did a discover and then we got an offer. Now you advertise and solicit. Slack is a most common one on it that you'll see out there. And what Slack does is, all it needs to know is the network address. And it proceeds to build a address for the individual machine, a host address, not off of a table like DHCP did, but it just creates it uniquely. What it does is it uses the MAC address. Remember, the MAC address is a unique address to every machine. So it uses the MAC address. It flips one bit. Let's see where it tells you that one like this. But it flips one bit to being the opposite of what it was. So if it was a 1, it sets it as 0, it's 0, it sets it as 1. So the MAC address isn't exactly the MAC address. But it's a common scheme, and everybody knows what that is. I'm not exactly sure why they did that, but that's what they did. Okay. The HPV version 6 is out there. It's got a stateful and a stateless approach to it. And so it can create off of that. The stateful, it actually sends the address to the machine. Stateless, it generates it off of it. But most of the time, what you're going to see out there is they're going to use Slack. S-L-A-A-C-K. Just going to use an extra A in Slack. And then talk about how you can generate these, and they go through and do a little bit on that one. shouldn't have a whole lot on that. And remember, this is just 1 out of 17 tests are taken. So if you do a few questions on it or whatever, and do not quite as well, you can still do really well. Okay. So there's a lot of new information right now. All right. Questions on all of that? Because then the rest of the chapter gets into multi-testing. So they talk about verifying on it that if you're going to verify on it, if it's on the Cisco equipment, you're going to do your show IPv6 interface brief, and it'll show you your address and everything on it. If you're looking at on your Windows devices, what command are we going to use to verify what our addresses are?
So,
ipconfig. Okay. If you were on a Unix machine, what do you use? Well, actually, on the Windows machines and on the Unix machines now, you would have used and been out there's ifconfig interface versus Internet Protocol. But actually, now IP is a command that's replaced it. Okay. Although, when I was watching the Security Plus trainer I've been in for the last 5 weeks. Finished last week, but I missed the 2 sessions when they were live, so I still got to watch the last half of 9 on the recording on the 10th. Is they didn't say anything about IP versus using ifconfig. Although other things do, so be aware of that one. Though. Come back there. So then they show you some different things on the Cisco ones that show IPv6 route, which would show IP route if you wanted to see the routing table. Okay, is what that's going to do. Ping command is still the ping command, whether you use an IP version 6 or use an IP version 4 address on it. Because it doesn't make any difference to it. Because the other part is, as long as you got DNS running, you can also put domain name there on it. The first thing ping does is converts it to an IP address. Multicast addresses, they talk about those at the end. And that multicast, again, are going to allow you to send messages to multiple machines, but not send them to all, okay? It's not broadcast, remember, where you're sending to a set of designated machines. But with IP version 6 multicast, you can send to a whole group of routers or send to all of your regular nodes on it. So you've got a little bit more power on that one. And then the solicited one, where it's being mapped to specific different machines out there on which interface you want it to connect to. They go through and talk a little bit about subnetting an IP version 6 network. But again, my comment to you on that one is, there's nothing complicated about it. All you're going to do is figure out which devices go on which subnet and assign them a specific subnet in that 4th hextet. You're just assigning a number of 4th hextets. So the subnet is no problem. Although they go through a few pages on it, and they tell you some on that, but they tell you about choosing the subnet to use. We'll use the subnet ID and use that 4th hextet. Just follow the scheme. You've got plenty to play there. Okay? It notes there that you've got more than enough subnets and more than enough hosts per subnet to work with off of that. Because you can have 65,536 subnets that way. And that's beyond where we are. And it will allow for 18 quintillion addresses per subnet. I've run into a network where I had to put 1 quintillion out there, much less 18 quintillion. Okay? Or even a trillion. That's when we're getting to quintillion and unit million addresses. We're going way out of there. Okay? So you got 20 of them there. They give you some pages explaining on that. I'm not sure why they spend as much time explaining on that, because all you gotta do is assign that number right there in the 4 text text. So don't complicate it. The book looks like they tried to take something here and complicate it. Questions on that? That gets us through 12. But some of this is a little bit shorter, some things are longer. The 11 had a whole lot more information in it. And our preference normally would be to set that one at 2 weeks. Now, 12, we've made it through it. You've actually got through 2 weeks from today to get the labs done. And I think there is a lab in 12. Is it? My machine has gone into.
I think that there's no labs in this one.
I'm pretty sure there's one in 12, but I'm not sure. But we skipped like 5 through 9 or somewhere along there, and then we get pretty solid, I think, labs from here on through the end of the book. So you've got, because next week we will not have class. Okay, because that'll be spring break. I think it is for y'all. It's high school too, isn't it? I was assuming that, and sometimes the school systems use different. GNTC usually sets ours up with corresponding to the public schools around here. I say usually, which is usually set up with around Easter, okay? However, a couple of years ago, GNTC had spring break on a completely different week. And everybody's going, what in the world? I looked at the calendar and when I see what the problem is, there's actually 2 Easters. I don't know if y'all know that or not. There's the Easter that the Western world celebrates, and the Orthodox churches, which is primarily churches in Russia, Turkey, and Greece, and that they usually have Orthodox in their name, but they were an initial split off from the Catholic Church, and so they're Eastern Orthodox is what a lot of people see them as, but they're Russian Orthodox or Greek Orthodox or Turkish Orthodox. They count the days on the calendar of which moon it is you count Easter off of differently, and there is. So if you look at a calendar, you'll actually see there's 2 Easters. There's an Orthodox Easter and there's Easter. Well, we normally celebrate in the United States the regular Easter. Apparently, somebody looked at the calendar from GNTC that year that was setting up the calendar, saw Easter and didn't notice it said Orthodox Easter and had no idea there was 2 Easters and picked their own week. So we had this strange week away from everybody else. And although other colleges are already having spring break, some of them had spring break last week, some other coming weeks, and so on. And then I think there's some colleges not even doing spring break this year. Because they're not wanting students to go anywhere. So we'll not have class next week. So Wednesday, let's do again like we did 2 weeks ago. We're going to have class this Wednesday. But what we're going to do is I want y'all to finish up working on and catch up on labs and cabling. Okay, so if you haven't finished your cabling, you need to get it done. You can work on it Wednesday. If you've got labs that you haven't done, and I know some of y'all can't do them at home because the Chromebook issue on it, and that you don't have another machine to put Let's get those done and get those in. Okay? Because they are running up penalties on them. And for that matter, if any of you want to take a test in here that day that you missed some tests, y'all can do that too. And then I can activate it. So I'll be here on Wednesday. The other part is on that, y'all can get me to set those up any other time, okay? So if you've missed the test and you're ready to take it, let me know and I can activate it for me. Send me an email and I'll activate it for you. Wednesday morning, if you're going to take it in here, you can just tell me that morning, sitting here, and I'll just type it in right then and we'll activate it. If you're not sure if you're going to take it that day or the next day when you write me about it, but you think, well, I'm going to take it somewhere and you write me this afternoon and you're intending you're going to get it in before by Friday, tell me when you write me. I'm going to take it somewhere by Friday so that I activate it through Friday for you. Otherwise, I'm going to normally activate it for the day you wrote me on and the next day. And then if you don't take it in that time period, you got to write me again to activate it again, okay? So if you'll tell me if you need a longer period of time that you're not exactly sure which day you're going to do it on, I can get it in there for you, okay? So let's get that all caught up and get it all straight on, okay? Let's use Wednesday to work on that. So I'll be here Wednesday morning. We'll have class. And so I'll be taking everything. It's just instead of doing lecture, we're going to do lab that day, okay? Allow y'all all to work on some stuff in class at that point and get back on track. So there's some of you that are behind, and some of you don't have as much on it, but y'all got, I think everybody's got something to do right now, okay, and that you can work on. The other part is, if you've already got everything done, you can actually sit there and help one of the other students that's trying to do their cabling, and you've got that all done and graded off, you can sit there and also assist them. Because on this one on the lab, on the cabling, y'all can get all the assistance you want. That part, I don't have a late penalty on the cabling lab. So if you haven't got that one done, you're not losing any points on that one at this point. Now remember, the last week we're going to come back to it again. We're going to do it again, that time without assistance. Okay? Although if you do need assistance on it at that point, ask me. First off, some things I'll answer the question on penalize you. And then the others, it's not going to be major penalties on you, okay? Unless you completely act like you have no idea in the world what you're doing. But if you just run into one problem, it's not going to destroy your grade or anything. Everybody follow on that one? And you've already done them. So and it may be you have to ask me something to get yourself started. The other part is that will be on the board for you when you do the final cabling, okay? The sides you can then bring figures on it, okay? But you can't go out on the internet and look. And you can't use your neighbor, okay? So that if I'm doing it, that I can't ask one of y'all, how do I do this? I'll lose points for it. But you've already done it, so that's not a big problem. And that is 10% of your grade, that lab final. Everybody follow on that? So when we get down to the end there, in that last week, 20% of your grade comes into play at that point. The online final, that's the cumulative final, just like what you've been taking everything. And you can go back and look at those tests. And it's 10% of your grade, and then the lab final is 10% of your grade. So that will jump your numbers up big time right there at the end. All right, any questions? But we got 9:45, so we've essentially used up the time today. But let's say, chapter 12, some of this stuff, they're not spending a lot of time on it, but they're introducing you to the terms on it. Because it's still coming on IP version 6. Now, people that take the class in a few more years, there's going to be much more emphasis on this and IP version 4 get less and less. And what we looked at in chapter 11, actually, in previous versions of the book, used to be 2 or 3 chapters. Subnetting was its own chapter in the past, okay? And now they're starting to cut down, and they've got it down to 1. And then gradually in time, they'll get shortened even further down. And the subnetting will go out the window at some point. But I don't expect that to happen for, let's say, at least another 5 to 10 years. Could be wrong. I don't always predict correctly, okay? But that's my expectation. But then back in '99, in all honesty, I would have told you the same thing on IP version 6 at that point. That in about 5 years at that point, I would have told you we're going to be IP version 6. But that was, that came on, and then that really held things much securer than I expected, and I didn't expect it to spread out that long to where we are now. And so we're still sitting at the same spot. It's just a thought of it up. All right, and that'll finish us up. So be here Wednesday morning, and let's work on stuff Wednesday morning. The next week, no class. Second thing is I'm going to be taking leave next week. And if you send me emails next week, you may have to wait a big bit till I answer them. I will try to look at emails generally every day, but I'm not necessarily going to, because I actually intend to get away for a few days and miss there too. Second thing is I actually take my second COVID shot next Tuesday, and that's the one that a lot of people say bites them. And then a lot of other people say it didn't bother them. First one didn't bother me other than I had soreness on the arm. But I'm scheduled for the second one next Tuesday, so I may be flattened anyway for a day or two, depending on how I react to it. But I've heard different people have different reactions. And that's the one that most people say is the one that has the biggest reaction. So we'll see on that too. And I didn't realize that one. I got the first one and scheduled the second one. And then the nursing people tell me I really need to go ahead and take it exactly on the time period on it and not delay it. But I said about delaying it a week. And I said, you really need to take it then to get the maximum effect. I'm not sure if that was maximum effect of it protecting me or the maximum effect of it bailing me out. Okay? But that was their comment, was to get the maximum effect. I really think it is to get the biggest benefit, but who knows? They may be going, let's see if we can do quite yet. But they said, I really don't want to delay it, so I'm going to go ahead and get it done as scheduled. And that would be also another factor to possibly stopping me from email also. So next week, that's what we won't be here. And whatever y'all do for spring break, I hope you have a safe and good one. Okay? And that we all need some breaks. So that will wrap today up, and y'all are through for today.